So, hello everyone, and welcome to my talk, Rust, the best and worst thing to happen to Tremor. So, first of all, that's me. Try to remember my face. Mario, currently a software engineer at Lyft, and I love open source. I've created and contributed to many projects, including, of course, Tremor. For contact, you can check out my personal website, nullref, which contains some social media links, or you can also send me an email. And so, yeah, today I wanted to tell you the story of when I contributed to Tremor with Rust as the protagonist. Basically about how the language shaped the development of my project with both its good and its bad aspects. Note that I did know Rust beforehand, but I hadn't dived deep enough until the mentorship, which is actually one of the reasons I went for Tremor. As some initial context, I basically joined Tremor through the Linux Foundation, which has this program that's called Linux Foundation Mentorship, through which open source projects can specify some task to be completed, right? And the nice thing about this is that you can, like yourself, you can find your favorite and then get it done, right? And at the end, you will get paid a bit and you will learn from your journey a lot and from your mentors as well. I would really recommend it for anyone that's starting in their career because unlike regular open source contributing, you actually have a mentor or multiple mentors that are giving you continuous feedback and are helping you through the journey. And it's also a win-win because the open source project gets help and grows its community. Who knows? Maybe you will end up contributing to the project after you're done. And for those who don't know, Tremor is basically an event processing system. You take events that may happen, maybe from a timer or from an HTTP server. Uh, you could think of those events maybe as logs, but they're actually a bit more abstract. But anyway, you take some sort of event and then you process them through the pipeline, which may include maybe filtering or all kinds of transformations like adding a field, removing a field, pattern matching, and such, right? And then once you have the events, you've processed them, you output them somewhere else, maybe a database, Apache Kafka, or even another HTTP server. And so to start our story, we have to go back to the very beginnings of Rust in Tremor, right? So let's take our handy time machine and go. If you, I would say, if you want to learn more about Tremor's history, please check out Gary White's video from last year. It dives super deep into why Tremor was created and how it happened, and you can learn a lot not just about Tremor, but also about system design and how it works in real life scenarios, right? But anyway, all we need to know about Tremor's history is that it was created to optimize Wayfair's event processing stack at the time. Like they did have one, but it was quite expensive and costly, so they decided to rewrite it or to write a new one with performance in mind since the beginning. And yeah, after establishing Tremor's use case, one of the first questions that arose are what tech the team was going to use and what language and frameworks the software was going to be written in, right? One of the options would be maybe Go, right? Go is super popular for distributed tools like Kubernetes, and it's already proven to be super nice for the server side. Yeah, you know, but it does have some disadvantages. One of the main ones was garbage collection, which is quite unpredictable. And so you would probably achieve the necessary performance, but you would spend your time tuning this garbage collector, which according to Darek was a pain. So yeah, along with other reasons, of course, but yeah, Go was discarded. And then we also have C and C++, which were definitely viable, but they also have tons of technical debt and overhead in that regard. So they decided to take a look at something else like Rust, this shiny new language, which made it easy to follow good practices and to write robust, scalable, and maintainable production code. Right? It's super modern and it learns from others, especially what I talked about earlier regarding C and C++. But it does have some disadvantages that I think aren't that well known, and it's what I wanted to talk about in this presentation. Um, anyway, like the performance requirements would be met, so they decided to give it a try. And yeah, I like to represent my journey with Rust as a flight of stairs. Right, you start at the bottom, knowing nothing, and then you advance step by step, slowly developing the product. And the objective is reaching the top, which means you're done. But you will see that it's not easy as that, of course. But yeah, anyway, choosing Rust was the first step of the journey in Tremor. And then it was actually the first step of many, right? Because Rust ended up being a great choice. and the team learned the language and became very productive with it. They built the program, like the core of the program, successfully with it and the first version. And so it kept going until we find our first problem with Rust, right? We fall into the abyss and into the unknown, which has to do with compilation times, right? So Rust made it possible to be really productive in writing high performance programs, but that also means that the compiler has to do lots of work for bigger code bases, right? That has to do with features such as generics, macros, type checking, or even optimizations, right? So Tremor wanted to prevent increasingly annoying problems with compilation times. To be fair, it wasn't that bad when I joined. It took like in debug mode, it took around 7 minutes to compile from scratch, and then each incremental change was around 10 seconds. Uh, which is worse than starting from scratch because like every change you made you had to wait for a bit, especially with linter and such. But anyway, it's like for a big project, it's not that bad. The thing here is that the goal was to future proof Tremor, right? Tremor has to support lots of technologies, lots of protocols, right? You take events from different sources and then you output them to different things, so you have to you need lots of dependencies to handle that without going insane, you know. And so, yeah, they started to look for a solution. And thankfully, there are many ways to approach this. I would recommend to check out Alexei's article for a few simple ideas that you can try. Maybe CI caching, avoiding generics, or optimizing your dependency graph, right? You can make it as parallel as possible. And so compilation would be really efficient. Or you can even profile compilation times to find like the worst dependencies in that regard. But I would say those are rather short-term solutions, right? If your project is big and requires lots of dependencies, then there's not much you can do about it. It's just gonna be big and it's gonna take time to compile, right? And so Tremor developers wanted something a bit more long term. And I would say the most impactful solution is a plugin system because it works at the design level, right? So the thing is that for a plugin system, you split up the binary into smaller components that can be compiled independently. And so since they're separate, if you work on one of those components, you don't need to compile the rest of them too, essentially dividing the compilation times. And that way we could actually continue to use Tremor without as much usability overhead in the compilation times. And actually, like using a plugin system is really nice because it brings other benefits, such as maybe like the flexibility of loading functionality at runtime, or even the modularity you get from this new architecture, right? And yeah, we would make it, but it turns out that implementing a plugin system in Rust is far from trivial. So we'll have to take it slow and go one step at a time, reaching smaller milestones, right? The first milestone is going to be the technology, right? So you can see here that at this point I've given up in my career as an artist. I don't know how to draw IPC or dynamic loading, but whatever, you get the point. We have lots of technologies to choose from, and we're going to have to take multiple factors into account. This technology should first of all be secure. It should also be backward compatible with respect to previous and future versions of Tremor, right? Like the plugin system is going to stick in Tremor and it's going to continue to evolve. And for the same reason, this technology should also have a future, right? It shouldn't get obsolete in just a couple of years. And this technology should also have great support in Rust, like in terms of usability, popularity, and it should also be cross-platform, right? Tremor supports Mac OS, Windows, and Linux, so it should continue to support them after the plugin system. But anyway, out of all those factors, the most important one is going to be performance, as I talked about earlier. So yeah, let's go ahead and take a look. One of them, for example, could be interpreted languages such as Lua, Python, or more specific ones like languages created specifically to be embedded into Rust, like Ray. They're super nice because they're easy to use and secure, but unfortunately, it means that you would have to rewrite the existing code into the language, right? Like all of those implementations in Tremor for like taking events and outputting events, like by turning them into plugins, we would have to rewrite them into Lua from Python or stuff like that. So yeah, it's not viable for our specific use case, so we're gonna have to discard it. And I would say everything is a bit more fun with epic explosions. So yeah, we can put our glasses on and blow it up, and continue maybe with inter-process communication IPC, which may include maybe sockets, pipes, or shared memory. So for sockets and pipes, they're super easy to use, right? They're very popular, maybe like with tactics or even with the standard input and standard output to communicate between different processes. But they're unfortunately not efficient enough for our use case, right? And like the one that's remaining in IPC is shared memory, which is very performant, but unfortunately also wildly unsafe because it's not well integrated into Rust at all, right? Like there are some libraries, but it's you have to use unsafe everywhere, and it's really not a good idea. So we can say goodbye to IPC as well. Another option we have is portable binary code formats, right? We can take a look at WebAssembly or eBPF, which are going to be more performant and usable than the interpreted languages because you don't need to rewrite the code, right? Your Rust code can compile to WebAssembly, and it's also a bit more secure because they usually have some sort of sandboxing capability, right? But unfortunately, after some experiment and some research, it's still not performant enough for our use case. So yeah, and someone probably called the cops at this point, so I'm gonna stop blowing stuff up, which is gonna be okay because we're only left with one technology to choose from, which is dynamic loading, right? So it checks all the boxes, including performance, but unfortunately it has bad security and not the best support for reasons we'll see later. Like it does have good libraries, but not so good language support, right? Like integrated into Rust. And so yeah, dynamic coding is very popular in C and C++. It basically consists on splitting up our binary into smaller binaries, right? And so there's two kinds of binaries. We have the plugins, which export some sort of functionality, and then we also have the runtime, which is able to load like this functionality from the plugins while it's being executed, right? So for example, we could have a plugin that exports a series of functions and a series of data structures to add support for JSON in Tremor, and so the runtime would be able to load this functionality after the compilation, right? It's also going to be very efficient because it works at the binary level. So like literally what's going on here is that the runtime literally copies the plugin into its own memory in order to access the resources and make the calls directly, right? So we are going to meet the most important requirement I mentioned earlier. And it seems to be a great choice actually. Like I tried out the first prototypes, and it did seem to work. Calling functions externally declared in Rust, and even importing and exporting data types in pure Rust seemed to be viable. However, it's not as easy as it seems with Rust specifically, because even though there are no warnings from the compiler, calling external functions declared with Rust and accessing external structs is actually undefined behavior. This all has to do with the ABI, right? The application binary interface. It's a concept that defines multiple things, such as the memory layout of any type you declare, or the function convention you use like between binaries, right? And so Rust obviously has an ABI. It does have one because it has to call its own functions and access its own resources, like within the same binary. But we call this ABI unstable, right? Which means that these protocols can change with every compilation. So essentially, like we need for this plugin system, we need to compile the plugin and the runtime separately, right? That's the whole point. That we want to split up our compilation in different processes. And so since like our ABI is unstable, we don't know exactly how to communicate between different binaries, right? So essentially, a plugin system is going to be impossible in Rust. And the worst part about this is that it wasn't so clear at the beginning, which is why I represented it as falling into the void. Many sources, I think, misunderstood the concept, and the community was slightly confused. But yeah, like actually, like having an unstable ABI is good many times, like often, because it makes it possible to change, among other things, like the internal memory layout of data types, and so we can fix stuff that's in. For example, most recently, there was this fix in the standard library for mutex, in which like the internal representation of the mutex changed completely, right? And so if we have some stable ABI that never changed for this mutex, we would unfortunately not be able to do that change, which is what would happen, for example, in C. But thankfully, like we can continue to improve Rust, at least like in this first stage of development, right? But yeah, for our use case specifically, it's not gonna be good, definitely. And yeah, thankfully we do have a solution, so we can dig ourselves out of the hole. But it's not the best, right? Because it basically consists on resorting to the C API, right? So our interface between plugins and runtime has to be at the C level. Don't think of seagulls. I'm talking about like being as bare bones as possible, not having any generics, or well, we can't even use standard library types, which is especially like that's the worst point, because many external types also use standard library types, right? So if you're using like a library for your database, it most likely also has like a string inside it, or like any more complex type declared in Rust, and so we can't even use external types, right? And so that's going to be most of our work, trying to make our interface between plugins and runtime uh, use the C API, and we would actually uh, eventually reach top. And so we know we can use C, right? But the question is, how do we improve the productivity, right? Full-blown plugin system for a large code base is going to be really hard if we stick to C for the interface. For that, we can rely on existing libraries, frameworks, or tools, and we can start to learn and use them, right? Even though sometimes it's not going to be easy to learn, such as in the case of ABI stable. API stable provides like a standard library with a stable API, right? It's declared from scratch with the C API, and it also provides a few more tools to define our own custom types and such. So it's not going to be only easier to use, but also much safer to write the plugin system via the static typing and some macros it provides. And then we also used async FFI heavily because Tremor uses async, and so that makes it possible to use it in the plugin system as well. But unfortunately, those libraries aren't really production ready, right? That's the main issue here. There were many features that were missing, or even bugs that we had to fix ourselves, and it took at times weeks to solve, right? So, for example, ABI stable is a huge effort. It's absolutely incredible. Honestly, props to the author, but it's also like one man's work. You know, there's not a lot of usage in the community. Like it's not too bad, but like it's really big, and there aren't that many contributors. So you do find a few issues from time to time. For reference, for example, I ended up creating like around 13 pull requests internally, like within the Tremor repositories, and then 33 external pull requests, like to dependencies such as ABI stable and such. So yeah, it's definitely going to be possible to use the libraries, but it's going to take more time. But in the end, anything is everything is going to work, and it will get easier as like those libraries get more usage. Uh, but yeah, it's not the best. I wrote a few articles about it in the personal blog to try to improve the situation myself. Another story is like at the beginning we were talking about how Rust is a modern, robust, and efficient language, right? So how can we use it to like its maximum potential to continue improving our performance and productivity? This has to do actually with the issues I found with fixing dependencies, right? Because they do use some advanced features. So Rust is like a really vast language with tons of advanced features, and we can use them to make our code tidier and more idiomatic, right? I can't even imagine how big Tremor would be if we were to write it with C. Like for example, the ones I used the most were macros, generics, or types. Like the static type system was super nice as well, or even create features from time to time. But yeah, the thing is that these advanced features may not be fully finished, properly documented, or even easy to discover, right? Maybe not so much with the ones I mentioned because they're fairly popular, but this especially happens when we go outside the Rust official book, or like when we start to get into features from the Rustonomicon. So yeah, like my specific example, maybe to be a bit more concrete, has to do with subtyping and variance, right? So subtyping and variance makes lifetimes in Rust more flexible in some edge cases, right? So I don't expect you to learn what variance and subtyping are just in this talk, but I guess it's nice to know about it. So like basically every type has a kind of variance, right? A type can be invariant, it can be covariant, and it can be contravariant. In the coding there, you can see that there's two functions that are basically identical. The only thing that changes is the type. At the top, we use cow, the type from the standard library, and at the bottom, we use rcow, which is a re-implementation of cow, but with the C ABI, right? That has to do, like this is part of the of ABI stable, and it's something that I had to fix, so it has to do with the previous story as well. The thing here is that cow is a covariant type and rcow is a invariant type. It's an invariant, right? So uh, you don't really explicitly indicate the variance to Rust. It's inferred automatically from rules in the compiler based on how the type is declared, right? So in order to know that cow is covariant, you would have to check whether you meet those rules, and same goes for rcow. So this can actually be important in some cases, like you can see in that function. And comparing lifetimes isn't gonna work for invariant types, but it will work for covariant types. And it is going to be really hard to know what's going on because it's like such a tiny difference and it's implicit, so it's not really anything in the code. It's like you have to check, you have to know about this topic, and you have to follow those rules. Uh, and unless you're using a new, like this happened to me a bit earlier when there weren't even warnings regarding variance. Like if you run into this issue, it just like spit out some random lifetime issue or like error. And now, like in newer versions, this is getting better because there are like the compiler does include some warnings, like hey, this type is invariant. Make sure you either refactor the function or make it covariant, right? I know that was the explanation was probably too short and vague, but unfortunately I don't have time to get into like how everything works in subtyping and variance. You can check out these resources, uh, and but unfortunately I would say this is not something good about Rust either. Researching advanced stuff in Rust is going to be harder than in C++, just like due to the popularity of the language. And that actually looks like plenty of docs in this slide, but unfortunately there it's not like super easy to discover because it's not like a popular topic. It like some of them are a bit outdated and not so well explained. Maybe like the reference page could definitely do with some refactoring and such. I would like if you want to learn, I would check out especially like John's video, but it's like I would warn you, it's like 3 hours long, so maybe like check out. Don't worry about the reference page or like the Rastonomicon is gonna be fine for like a short read, so that's fine as well. But yeah, like I basically had to spend a couple of weeks working on this until it was fully fixed. Thankfully, I had the help from the Tremor team and even the creator of ABI stable with the like final implementation. So that proves that even though we go through these issues, the community is actually super nice and it's super easy to contribute to the libraries in the community. Yeah, that was basically near the end of my project. I unfortunately didn't manage to complete the plugin system as it was specified in the beginning, right? I was missing a few features and such, and unfortunately performance was degraded by 30%, right? When it should be around 10-20% for production. But I think that my work is useful not only for Tremor, but also for the whole Rust community, right? Like those contributions I think helped a bit. And instead of going like up the stairs one by one like I did, they can take a shortcut to finish it as you can see in the picture. And so the main takeaways from here I would say would be that Rust is a huge step forward, but it's far from perfect, right? We have some issues with compilation times, which can become a problem with large projects, especially. And there are some fixes, and it's not like C++, for example, is any better, but it does hurt productivity. So my tip would be to keep your architecture for your program modular, not just like in terms of libraries or modules, but also like in terms of like trying to split up your program into different services or different plugins. It depends on the case, right? But like different binaries. Also, like being so fast paced, it doesn't have a stable ABI, which, as I said, is mostly beneficial, but not really in our specific use case. So if if you're gonna rely on having a stable ABI, think about it twice, and if you go for it, make sure your interface stays low level from the beginning, right? Try to define it as close to C as possible, because the problem I would say is when you're trying to make Rust, like a full-blown Rust program, use the C API. And it's also a very new language in comparison, right? So it can have some lacking documentation or even libraries in some cases. So my tip in that case would be to contribute yourself whenever you can, because it's a really nice experience, and that's the best way to progress forward. And yeah, lastly, I would say that some advanced features are either only available in Nightly or incomplete. Definitely having Nightly on production is a really bad idea. So my tip would be to try to find a way around those issues, because 99% of the times there's going to be a fix. And I would also recommend to check out the Nomicon in detail, even if you aren't going to use some of the features in there, just like reading and being aware of them is going to be useful for sure. There are other uh, criticisms to Rust, definitely, uh, such as maybe having a steep learning curve, or like the complexity you can have at times. But like the ones I mentioned here are the most relevant ones for my personal experience with this project. Still, Rust is a fantastic language, and I would say, like, please, if you come across any issue, something that's not well documented or popular, please help. It's usually super easy, and like everyone's super friendly. One PR away, and you're making a bit of progress in this language, in this new language, right? Also, I would say take this talk with a grain of salt, right? Always do your own research. It only like this only focuses on the bad parts, and it's somewhat anecdotal. So yeah, like after all, it's a nice language, but it has the inconveniences I talked about. If you have any questions, I'll be available now. You have lots of details about the journey on my personal blog. I wrote everything in there as I was working on it to try to help out the community, and I still had to even write a couple of articles, especially like about the lifetime issues I found, and such. I would also recommend to check out Tremor's site, which has tons of information about it, and to hop on the Discord server to say hi. So that was all, and thank you very much.